Hey guys, welcome back. For today's video session, what I'm gonna do is to introduce to a new sensor that is SI1132. Now let's have a look over this sensor in a better way, and for that log on to the website that is controleverything.com and here search for this particular sensor that is SI1132. Now what we got for the sensor, that it's a UV index ambient light sensor, and these are some of its features you can see on my screen. Also, you can purchase the sensor from here. Well, I will be interfacing the ambient light sensor UEDEX SI1132 with a Raspberry Pi and a Python code, and I will be going to the resource tab to get the code. And here comes the Python code sample, as you can see on my screen, and I can download the code as the file from here, just like that. I have the opportunity to download the code from another source, that is github.com, and the repository there is Control Everything Community. Now let's make some connections for the hardware we require to show the working and interfacing of this sensor. Now coming to the hardware section, first of all the requirement is of a Raspberry Pi, which you are able to see on my screen, and this here is an I2C shield. It's available on the website controleverything.com, and the reason we are using this shield is to make connections with other I2C devices, and the connection should be a lot easier. That's why. Now the next part is to gently place this I2C shield over the GPI pins of the Raspberry Pi and make a connection. Now what we require is our sensor, that is UV index ambient light sensor SI1132, and this here is a connecting cable. Make the connection of the cable and the sensor, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same goes for the I2C shield. Now to power up the Raspberry Pi, what we require a micro USB cable just like this, and gently insert it over the power jack. The last part is to provide the internet connection, and we have two ways. The first is an Ethernet cable, which you can see on my screen, and gently insert it over the Ethernet jack or LAN cable, as you can notice. Now the second part is that if we don't have the first part, that is the Ethernet or the LAN cable, we can have the opportunity to make the connection via a nano adapter wireless, which you can see on my screen. Here it is. Now we are done with the internet connection. So all the connections we need to put up this setup, we are done. Now what we require is to have a look over the code, and let's interface. Now for the interfacing part, first of all we have to go to github.com, and here we have to search for the repository that is Control Everything Community, which you are able to see on my screen, and there you go. And this is the code. This is the sensor SI1132 we are looking forward, and here comes the Python code. But before that, let's go to the Python code instructions we have to follow. It says that we have to download and install SMBus library on the Raspberry Pi, and this link will help us to step-by-step installation of the SMBus library. Please note down the examples, dependencies, the commands you need to follow to install the library SMBus. Please note it down. And this is the command to run the Python code. Note it down also. Now get back to the Python code. As you can see, it's a .py extension file. Now you can see that we have imported SMBus and time libraries, and we have the address of the sensor, that is 0x60. Then we have enabled UV index measurement coefficients here, and these are 4 coefficients we have gone there. Now coming to the writing part, we have selected param WR register, that is the write register having address 0x17, and we are sending the command here, that is 0xf0 goes for enable UV visible and IR, and this is the write command. Now we are selecting the command register having address 0x18, and we are sending the command to select ch list register in RAM, that is 0x01 or with 0xa0, and this is the write command here. Then we are reading the data back from the register, that is 0x2e, and here comes the command. After that we are selecting int output enable register having address 0x03, and 0x01 command is for int pin driven low, and this is the write command here. Then we are selecting els interrupt enable register having address 0x04, and 0x01 is the command address, that is assert int pin whenever visible or UV measurements are ready, and this is the writing command for that. Then we are selecting HW key register having address 0x07, and we are sending a command that goes for 0x17 address, and it's the default value, and this is the write command for that. Then we are selecting param write register having address 0x17. We are sending the command that is 0x00, that is for small IR photodiode, and this is the right command for that. Then again we are selecting the command register having address 0x18, and we are sending the command to select ALS IR ADC mux register in RAM, that is 0x0e 0x A0 or with, and this is the writing command for that. Then we are reading data back from the register, that is 0x2e, it's a param read register, param RD register, as you can see, 1 byte from that. Now coming to the part again for the writing section, we are selecting param write register having address 0x17, and we are sending the command to set ADC clock divided by 1, that is 0x00. Here comes the writing part. This is the writing command. Then we are selecting the command register having address 0x18, and 0x1e or with 0xa0 is the command to select ALS-IR ADC gain register in RAM, and this is the right command. Now we are reading data again from the register, that is 0x2e. Then after that we are selecting the param write register having address 0x17, sending the command that is 0x70 goes for set 511 ADC clock, and then we are selecting command register having address 0x18, and we are sending the command that is 0x1d or with 0xa0, that is select ALS-IR ADC counter register in RAM, and the right command is here. Then we are reading the command as the response from the register, that is 0x2e. Then we are again selecting the register that is param WR having address 0x17, and we are sending the command that is 0x00 goes for set ADC clock divided by 1, and this is the right command for here. Then we are selecting the command register having address 0x18 and sending the command that is 0x11 or with 0xa0 goes for 177, select ALS with ADC gain register in RAM, and the right command is here. Then we are reading the data back from the register, that is 0x2e for 1 byte. After that we are selecting param WR register having address 0x17, and then we are sending the data for high signal range, that is 0x20, and the writing command is here. Then again we are selecting command register having address 0x18, and 0x1f 0x or with 0xa0 is the select ALS-IR ADC MISC register in RAM, and the writing command is here. Then again we are reading the response from the register, that is 0x2e 1 byte. After that we are selecting the param WR register write register having address 0x17, and 0x70 is the command to be sent for setting 511 ADC clock. Then we are selecting command register having address 0x18, and we are sending the command to select ALS VIS ADC counter register in RAM, that is 0x10 or with 0xa0, and the right command is here. Then we are again reading the data back, that is the response from the register, that is 0x2e for 1 byte. Then we are selecting the param WR register having address 0x17, and we are sending 0x20 for high signal range, and the writing command is here. After that, this is the part for the last writing command. As you can see, we are selecting command register having address 0x18, and 0x12 or with 0xa0 is the command to select ALS VIS ADC MISC register in RAM, and the writing command is here. Then we are reading data back from the register for this very command, that is 0x2e 1 byte. After that we are having the reading part, where we have selecting the param WR register having address 0x17, writing here 0x0e to start ALS conversion, and the writing command is here. Then we are reading data back from the register, that is 0x22, that is 4 bytes, that's the visible and the IR. As you can see, the conversion of the data takes place here, which is according to the data sheet provided for SI1132. Then again we are reading data back from the register, that is UX2C for UV. As you can see, ultraviolet, and the conversion takes place here for UV data. After the part, what we gonna do is to show the output data on the screen, which is the visible light of source, IR of source along with the UV of the source, and the unit is common, which is of the luminance, that is lux. So this is how the code looks like. It's a bit lengthy but very generalized and simple code. Now what we're gonna do is to show the working, the practicality of this code. Let's have it. Now coming to the working environment, first of all the part is to copy this entire code of the Python as you can see on my screen, and open up the terminal via internet for the Raspberry Pi. Here create a new file SI1132.py, which is the extension, and paste the entire code of the Python, and now save it. And this is the command to run the code as you can see on my screen. And here we go, we have the visible light of source IR and the UV of the source as you can see in the lux unit. And when I'm sending the command again and again, you can see there is a very small change on the three values. Now this means that there is no interference regarding the light source, but when I place some object source over the sensor, you can see there is a very slight change. It changes, but there is a slight change, and again there is a slight change. But when I place some light source over the sensor, you can see the changes for all three values of visible, IR and UV. When I bring closer the subject, the IR source, light source, you can see the changes. So this is how the sensor responds regarding the Python code along with the Raspberry Pi. Now what we want to do is to show the benefits, applications of the sensor SI1132. The SI1132 is a low power ultraviolet index and ambient light sensor with I2C digital interface and programmable event interrupt output. This sensor IC includes an analog to digital converter, integrated high sensitivity visible and infrared photodiodes, and digital signal processor. The SI1132 offers excellent performance under a wide dynamic range and a variety of light sources including direct sunlight. This includes a wide range of applications such as fitness, health, electronics, tablets, smartwatches, smartphone handsets, display backlighting control, and a lot more to mention. This sensor can be purchased from the website, that is controleverything.com, and you can have the code from the resource tab, and after that you can download the code as a zip file. You can also have the code from GitHub repository, that is Control Everything Community, and you can download it from there. Now, in the end, I would just like to make it clear that at any point, if you have any further queries regarding any part of this video tutorial or the sensor, you can contact us on controleverything.com and put your comments on the community page of this website. For blogs and articles which are relevant to this sensor and video, go to our blog instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. Now, I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.